and 99% of dinosaurs vanished, yet their silent stories remain. But how long did these titans truly walk the earth? Determining dinosaur lifespan is a formidable paleontological challenge. We cannot observe them directly, we must read the evidence. The primary method involves analyzing bone microstructure, similar to tree rings. But these growth rings, or lines of arrested growth, tell a story. A wide ring suggests rapid seasonal growth phases for the dinosaur. But this technique carries inherent uncertainties and assumptions. Now that we understand bone analysis, let's explore species variation. Smaller, age-old dinosaurs often exhibited much faster life cycles. Many smaller dinosaurs matured rapidly, reaching adult size quickly. Some estimates suggest these species lived perhaps only 20 years. Contrast this sharply with the colossal sauropods. These giants needed immense time to reach their unbelievable sizes. But growth rates were agonizingly slow, spanning decades just to reach sub-adulthood. And their bones show evidence of continuous, incremental development. This steady accumulation suggests lifespans rivaling modern elephants or whales. Conservatively, many large dinosaurs likely reached 70 to 100 years. Now that we understand growth metrics, let's look at bone chemistry. Isotope analysis offers an independent verification path for aging. Oxygen isotopes locked in the bone record environmental temperatures over time. But this helps correlate growth periods with specific ancient climate shifts. Consider the predator. The apex carnivores often had different life strategies. Apex predators typically mature faster, trading longevity for immediate dominance. But their bones often show signs of stress and repair from frequent conflicts. But these raptorial dinosaurs seem to hit peak size by their late teens. But this contrasts with herbivores, whose sheer mass required extended growth periods. Survival for the largest meant investing decades into simply becoming too big to attack. The internal architecture of their bones reveals this slow, deliberate construction. Now that we understand the physical evidence, consider ecological pressures. The Mesozoic world offered stable, warm climates for much of its duration. Abundant resources might favor slower metabolic rates and longer lives. Cold-blooded reptiles live long due to lower energy demands. But dinosaurs were likely somewhere in between, active but large. The study of histology reveals the actual cellular aging processes. A growth plate fusion, typical in mammals, often happens later in dinosaurs. This points toward indeterminate growth, a hallmark of extreme longevity. An evolutionary selection favored those who could survive the long juvenile period. And now that we understand the potential, let us examine the record holders. On the horned dinosaurs present, some of the clearest aging records. An evidence suggests many ceratopsians lived relatively shorter, intense lives. But the heavily armored dinosaurs also show moderately fast maturation curves. But their defensive investment may have negated the need for extreme longevity. They needed to survive infancy, but perhaps not centuries. The largest candidates for longevity remain those massive, slow-moving herbivores. Their immense body size demanded decades just to reach reproductive maturity. And these innermost rings are often fused, masking the earliest years. But a slow metabolism equates to less cellular wear and tear over epochs. However, the ultimate barrier to knowing is the fossilization process itself. Perfectly preserved growth records are exceedingly rare discoveries. Erosion and diagenesis destroy the microscopic details we rely upon. But every lifespan estimate carries a significant margin of error. Yet, the consensus leans toward long lives for the true giants. Imagine surviving environmental changes across 3 or 4 human generations. Teeth also offer clues, showing replacement patterns over decades. The transition from rapid juvenile growth to mature maintenance is key. And even apex predators like the tyrant king likely lived past 50 years. But each massive bone fragment represents a massive investment of biological time. The diversity in dinosaur lifespans mirrors the diversity of their forms. Ultimately, these estimates anchor these magnificent creatures in our own timescale.